Hello students, in this lecture of automobile engineering we will study about automobile control system. This is unit number 3. We have finished unit number 1 and unit number 2, and on the basis of that units you will have to face the sessional test examination number 1. Now what are the contents? You are seeing here the pictures. On the left hand side you will see the braking system, and on the right hand side you will see the steering system. So these particularly two important control system that we will learn in this unit number 3. What is control system? A control system is a system of devices or set of devices that manages, commands, directs or regulates the behavior of other devices to achieve the results or desired results. So management, giving the commands, direction and regulation, these are some of the basic functions that control system does in automobile system. What are the contents of unit number 3? Let us see one by one. Number 1 is 3.1 automobile braking system. Number 3.2 is type of braking system. 3.3 is parts of braking system. 3.4 review of anti-lock braking system. 3.5 automobile steering system. 3.6 types of steering system or steering gearboxes. And number 3.7 is steering geometry. So from 3.1 to 3.4 is the braking system, and from 3.5 to 3.7 there is a steering system that we are going to learn. But in this video particularly we will learn about only automobile braking system and its in short what are the contents. Let us see what we are going to learn in this lecture. What is the function and requirement of braking system? Second is what is the principle of braking? And third one is basic terms related to braking like stopping distance, braking efficiency, fading of the brakes. What is the purpose of braking system? Let us see. The first purpose is to stop the vehicle by converting kinetic energy to heat energy. Heat energy is created in the brakes by friction. Friction is created between a moving and non-moving surfaces at each wheel to generate the heat. Disc and drum brakes are most common type of braking system used. What is brake? Brake is the device used to stop any vehicle by applying frictional forces. One of most important control component of vehicle, it is called as a brake. They are required to stop vehicle within smallest possible distance, and this is done by converting kinetic energy of vehicle into heat energy which is dissipated into atmosphere. Let us see what are the requirements of braking. Number 1, brakes must be strong enough to stop vehicle with a minimum distance in emergency. And number 2, brakes must have good anti-fade characteristics. That is, their effectiveness should not decrease with prolonged application. This requirement demands cooling of the brakes, and it should be very efficient. This is the braking system that you will see in the picture. What is that? An automatic braking system is a group of mechanical, electronic and hydraulically activated components which use friction or heat to stop a moving vehicle. So what are the components? Mechanical, electronic and hydraulically activated components. Let us see what is the principle of braking. Common principle on which a braking system depends when stopping a car is a friction and heat. So friction and heat, these are the two basic principles used in braking. By applying a resistance or a friction to turning a vehicle's brakes cause the vehicle to slow down and eventually stop, creating heat as a byproduct. So heat is a byproduct and friction is nothing but the applying resistance. The rate at which a wheel can be slowed down or depends on several factors including vehicle weight, braking force and total braking surface area. This is a picture showing you the phenomena of friction, static friction and dynamic friction, static friction and kinetic friction. So static friction is there between the road and the tire, and kinetic friction you will observe here between the brake and the wheel of the automobile. When the brake is applied, you will see that braking tends to force down front wheel and the braking tends to lift the rear wheels. So this is a phenomena of applying the brakes and the phenomena of friction that you are going to watch in this picture. What are the factors governing the braking? Number 1 factor is pressure, number 2 is the coefficient of friction, number 3 is frictional contact surface, and number 4 is heat dissipation. What is stopping formula? When the body is moving with a certain velocity and suddenly brakes are applied, you would have noticed that the body stops completely after covering a certain distance, and this is called the stopping distance. The stopping distance is the distance traveled between the time when the body decides to stop a moving vehicle and the time when the vehicle stops completely. The stopping distance depends on the factors including road surface and reflexes of the car's driver, and it is denoted by a symbol small d. How it is calculated, let us see. D is equal to v square upon 2 into mu into g, where d is nothing but stopping distance in meter, v is the velocity in meter per second, mu is frictional coefficient, and g is the acceleration due to gravity. And second formula is d is equal to kv square, where k is nothing but constant of proportionality and v is the velocity. These are some of the simple example based on stopping distance. In this example, you will have to use the formula d is equal to kv square, and coefficient constant of proportionality k is that you have to evaluate. For that purpose, velocity is given v is equal to 40 meter per second and stopping distance d is equal to 10 meter, and you will have the solution k is equal to 0.00625. This is the example number 2, in which you have calculated, we have calculated here stopping distance d is equal to kv square by using this formula. So d is given or evaluated as a 202.5 meter, for which we have provided velocity is equal to 15 meter per second and constant of proportionality k is equal to 0.9. What is braking efficiency? Efficiency eta means braking efficiency is evaluated as v square upon 3d, where v is equal to velocity of the vehicle and d is the stopping distance. And below to that, you will see the condition of brake. When the brake is perfect, efficiency is 90%. When the brake is excellent, efficiency is 77%. When the brake condition is good, then braking efficiency is 70%. Below fare is a very danger of the braking efficiency. This is a chart of stopping distances. When the efficiency is 100%, then at 30 km per hour, you will see their value is 3.5. At 50 km per hour, the value is 9.8. At 80 km per hour, the value is 25.2. And at 100 km per hour, the value is 39.3. So this way, on the basis of efficiency, we can have the values for stopping distances in meters. What is brake fare? When with a prolonged application of the brakes, their effectiveness decreases, and this is called as a fading of the brakes. Higher vehicle speeds give rise to excess temperature during the braking. Drum temperature may rise up to 250 degrees centigrade. See the temperature range 250 degrees centigrade during the braking. At such a high temperature results in fast wear of the linings and brake fade. That is, heat temporarily changes the friction properties of the brake lining and brake pads. A hard brake lining fade sooner, and this leads to vehicle skid. So vehicle will skid if the brake fades. The brake drum must be of such material that it may quickly dissipate the heat developed during the braking. So this is the phenomena of brake fade that occurs inside the braking. So these are some of the references. You can refer these links for more information. Thank you very much.